If we want to know if a material is soluble, we want to know if the dissolving process is spontaneous. For that, we need to look at delta G for dissolving. But that doesn't tell us whether a lot of solute dissolves or only a little. For that, we want to know if the process is extensive. And for that, we need to look at delta G0. We have our relationship from the second law of thermodynamics. Delta G equals delta H minus T delta S. We can use this specifically for the solution process. On the last page, we talked about delta H of solution, the enthalpy change for dissolving, and how we could imagine a three-step process. Solute breaking interactions coming apart, solvent breaking interactions coming apart, and solute and solvent mixing together to form new interactions. We should be able to write a similar relationship for entropy. Now, we might guess that a solid going to an aqueous solution would result in a scattering of the solute particles with many more ways to arrange them, resulting in a positive value for delta S. Certainly, breaking apart the solute interactions should increase the entropy. Probably the same for creating solvent cavities. However, when solute and solvent mix, creating new interactions between solute particles and solvent molecules, it forces order into the overall structure, decreasing the way that the solvent molecules can be arranged. This would correspond to a decrease in the entropy. And as long as we're dealing with solid or liquid solutes but no gases, the overall delta S of solution is probably small. As always, the criterion for spontaneity is a negative value of delta G. So if delta G of solution is negative, then the dissolving process is spontaneous. In that case, we would say that the material is soluble. If delta G solution is positive, then the dissolving process is non-spontaneous. In that case, we would say that the material is insoluble. We'll use these terms in a qualitative way when we talk about the solubility of ionic compounds. But as we recall from our discussions of plain delta G, having a negative value or saying a compound is soluble doesn't tell us how much solute can be dissolved. What we're often interested in is the maximum solubility of a compound. We might ask, when does a solution become saturated? And for that, we need to know about the extensiveness of a reaction. And for that, we need to consult delta G0. Delta G0 solution is the standard free energy for a dissolving process. It is the spontaneity of a reaction starting at standard states, which for a solution is 1 molar concentration. In other words, if we already had a mole of solute dissolved in a liter of solution, is dissolving still spontaneous? Could we still get more solute to dissolve? If the value of delta G0 of solution is negative, then the reaction is extensive. Still more dissolves. That means that the maximum solubility, or where the solution becomes saturated, is at greater than 1 molar concentration. If delta G0 of solution is positive, then the reaction is not extensive. No more would dissolve. In fact, the reaction should go in the reverse direction, with some solute coming out of solution. This means that the maximum solubility, when the solution is saturated, would be less than 1 molar concentration. Of course, if the maximum solubility is less than 1 molar, what we just described, starting at 1 molar concentration, is purely conceptual. But hopefully you can see that the sign of delta G0 tells us whether the maximum solubility is greater than or less than 1 molar concentration.